So basically, we work on sentiment analysis by using the tweets dataset we took on Kaggle. We has it in on local, so we import it here. We use many libraries, TF, IDF, logistic regression, train test fit, and all that stuff. And the work was we were supposed to build a model that can be able to predict the sentiment related to a sentence, whether it's positive or negative or neutral. So here we display some text in the data set. We display some text concerning the data set. We can see, for example, we can see this sentence. For example, I have respond if I were going. For example, it's classified as neutral. So sad, I will miss you her in one day is negative and some other sentences are positive. So like the data was scrapped on Twitter. So it's come with a lot of noise and other content that are not really important for prediction. So we can work with it like this. Firstly, we start explore the data set. And the data set has approximately 27,000 sentences. 27,000 sentences. And each sentences, all the sentences are classified as neutral, positive, or negative. We can see that it's almost balanced. Like neutral has 40% of the overall data set, positive 31% and negative 28%. So it's not really far. It's not really unbalanced. So we check for not a number. We check for missing data, and we didn't have many missing data here. Some texts were missing just one, not much, just one text. One sentence in one row was missing. And we also check for duplicate, no duplicate. And like, because it's just one sentence, we drop the missing sentence. It's not useful for us. So we was interested on just one, two variables. We're interested on just one variable, the text and the sentiment for the target output. So we selected just the two variables, and we create a new data set with just these two variables. And by selecting it, we remove the neutral. We wanted just to have the difference between positive and negative for our example. So we just remove neutral and keep positive and negative. We remain with 16,000 of sentences. That's enough for the model to train well. Yeah. After that, we produce a word cloud representation to see how influent some words are in a specific sentiment. Like when I'm taking the overall data set, not considering positive or negative, I can see that words like good, love, work, now, thank are present. Some words like that are very dominant, Godfen, and some other words that are not really useful. And we split in positive and negative to see, okay, for each sentiment, what type of words are dominant? For positive sentiment, we can see good, love, thanks, hope, mother, great, days, nice. We can see several types of words that are very important in the positive sentences, happy and other stuff. And for negative, we can see work, miss, going, sad, sorry, sick, time, sleep, bad, done. Yeah. And after we treat the sentence by removing some unuseful, useless, some useless content, remove like arrobas, DS, star, remove links, remove some noisy things, and we apply the clean to have the clean text. Here we have a new column that called clean text. In this column, we train our model. And here is just a visualization of negative data set with negative sentences. We can see all that pattern: sad, boiling, alone. You can see dangerously. So such word that is good to predict whether a sentence is positive or negative. So we need to vectorize because model don't understand words. Model understand only numbers. We need to create a vectorization for the model we are going to use. For the model we are going to train. So we use a tokenizer and we pad a sequence to allow every sentence to be in the same has the same length. Yes, it's very crucial for the language modeling and text on the representation. Yeah, here we used TF-IDF tokenizer, and we obtain such kind of vectors. As you can see, this vector, for example, all the sentences are like that. If all the words are like that. Like for each word, we have an embedding vector. But this method is limited because it will provide the same embedding vector for every word without taking in account synonym or word that is writing the same but not have same meanings. Like we say, I save money, I keep my money in the bank. And if you talk about bank related to money, business, loan, other stuff. But if you say, for example, the bank of the river, for example, is not the same bank, but this TF-IDF vectorizer will characterize it as the same bank. So we split our data in train and test and train a sequential RNN model on. The preferable techniques we should use here is not TF-IDF vectorizer because it's limited. It's limited in terms of contextual representation. So we need for the next step to improve, we need to use like word embedding method like word2vec or gloss. Such kind of embedding method that take in account contextual representation and give different meaning for different words in different contexts. So after training the RNN model, we also train a GRU model to compare. After the training epochs, we visualize model performances. For the simple RNN model, we got 86% of accuracy, and we can see that for each classes, the model is balanced in terms of possibilities. The model is balanced. It's not like good in one class and worse in another. It's well balanced. So, but for the GRU model, we got better accuracy, 0.88% of accuracy, and performances across classes are also significant. We can see a significant difference between simple RNN model and GRU because GRU has the capability to capture long-term dependency. Like RNN can sometimes, if the sentence is too long, forget representation, misrepresent previous tokens because of compression of the information and pass it to the next layer. You don't have a gates architecture to save needed information, or like forget some others. But GRU, I choose GRU here instead of LSTM because GRU has less gates than LSTM and can be more efficient in long terms than LSTM. So there's our conclusion matrix. Sorry for the noise. It's our colleague's birthday, so there's shouting there. We can see that also in terms of confusion matrix, the model is not don't have many confusions. Some confusion is significant. Yes, it's significant in terms of confusion. Like 200, 100 is significant, but it's comparing to the other overall data set is not really much, but we can achieve better performance. And we also analyze the training curves. Like this is validation accuracy. We can see that RNN model stopped somewhere, where GRU model continue growing, and so on. And the same to the validation loss. So after we test the model on some sentences to be sure that everything is perfect. And we deploy it through Streamlight. We use Streamlight to deploy the model. Can you see this screen also? I'm on VS Code now. Oh, yes, thank you. So like you see previously, let me go back on the model. We saved this model to further application to use it after. We saved the model to use it after. And we have this files. Let me see, we saved it. Classification report. Let me see. Yes, we saved both models here. And we also save the tokenizer models because we need to apply the same embeddings to the sentence we want to predict. When we want to predict, we need to apply the same embeddings than the one we use to train the model. So we also store the tokenization model somewhere. We save it somewhere. Let's see. Okay, we also save it somewhere. Where is that model? We save it. I can find it here in the code. In Visual Studio, we have this tokenizer. Yeah, this tokenizer. We have this tokenizer. That is the model we train to tokenization, and we also store our two model, final GRU, final RNN Sentinel. Yes, sorry, sir. Yes. So finally, like because GRU was better than others, we use GRU here with this code. This code is basically the one who provide the interface I sent in the LinkedIn post, the one I deployed, using also the Streamlight server. Let me see, try to run it in local. Let's see that these things. Open the source, okay, dashboard, yes. So let's Streamlight something. Please Streamlight something. Python, okay. Yes, like you can see here, localhost version. This is a local version. Oh, If I show files, ah, okay, okay, okay. Here is a small mistake of this thing, of this file location. Let me correct. Yes, so it was a path problem. I changed the path of my my model file, so is why it's did that thing. So here is the interface generated by this code. Yes, it's a simple Streamlight code, and we enter a sentence. Thank you, my friend. Analyze sentiment. Positive with 99% of confidence. So I say I'm sad. Negative with 97% of confidence. So I say I'm not really sad. I don't know whether this can create error. For example, this is one of the limitations because of the contextual understanding, contextual embedding of the sentence. We don't have contextual embedding. We have local embedding, local representation of the words of the sentences. Is why some sentence that's not really negative will be predict as negative. So I think it's all. Thank you for your attention. Hello, sir.